So hello, welcome to my channel. Good evening to all of you. So in this lecture, as I mentioned, lecture 6, GATE 2020 chemistry. This is last lectures of this GATE 2020 papers. Actually, I made 6 lectures videos, which is very lengthy. Actually, I covered all questions related to this physical and most of the popular question which several time question in coming in CSIR as well as GATE. That's why it took too much lectures, but hopefully you guys understood the question solutions. So if you are new in this channel, so please subscribe and like the channel and click the bell icon so that you will get easily notification when I upload the video. Okay, so as you can see, question first, this is quantum chemistry and it's very good questions and lengthy question also. Solution is very lengthy, so maybe, but it's very simple. Okay, right, it's very simple. So question is, I am reading. Question says the percentage error which is rounded off 2 decimal places, means we have to find the percentage error in the ground state energy of particle in one dimensional box of length A. Box length is given A, which is described by a trial variation function phi is equal to x a minus x, where as you can see I have mentioned all these given data in the questions in the solution. Okay, given trial variation function is phi x a minus x and condition is given x is less than or equal to a, greater than or equal to 0. Okay, and some two ground state energy value also is given, Et h square upon atom a square. Okay, and some integration value is also given, means integration of 0 to a means box dimension size 0 to a, integration 0 to a phi star into phi d tau is equal to a phi upon 30. Okay, so simply we have to calculate the percentage error in ground state energy in one dimensional box, which is given a length of box is a. So simply by using actually the given integration value we have to use during the solving the problem. Okay, this value directly we can use. So simply we know the formula, this calculation of ground state energy E is equal to integration of phi star h into phi dx upon phi star into phi dx. Okay, so this value simply we can use either from here. Okay, or we can solve, then we, finally also this value we will get here here you can, as you can see I am not used this value here. I am not using, but you can use during solving the problem. You can use because in question is given. Okay, so here I did not use this value. I solve and finally I also get the solution of this integration, this. Okay, so basically because I am here giving you explain solution, that's why I used. But during the exam point of view, means if you are in the exam hall, then you can directly use as given the question value. Okay, so anyway, so this is the formula to calculate the ground state energy. So simply this phi star is here, is phi function is given here, trial variation function phi x my x into a minus x. Simply we put here phi star, and h cut is also we put here. Okay, this is Hamiltonian operator. Okay, and x phi, again we put phi, and simply we put here phi star and phi value, this value here I put, and this is the because both function are same, so the square of x square a minus x ka whole square dx. Okay, so simply we solve here. If this is the constant term and this is the constant term. Okay, simply you put outside. Okay, here I put here outside, this is a negative of this h square upon 8 pi square m. Okay, so now only integration 0 to a x, this is x into a minus x is outside, and this is a differentiation, double differentiation of this function. Okay, so this is outside, and now we'll differentiate to this function. Okay, this function. Okay, so if you differentiate this function, so you will get this value. Okay, this value, because if double differentiate, first differentiate, this x will become 1, and this 1 power you will remove. Okay, when differentiate again, then this will become 1, become a become 0, and this become minus 1, so minus. Okay, so here become only minus 1, so minus 1 here we got minus 1 here, this is outside, and simply multiply x into this bracket, so ax minus x square. Okay, now in denominator you multiply these things, x square a, first you open this bracket. Okay, first you open this bracket, as you know, a minus x square is called a square plus x square minus 2 ax. So I applied this formula. Okay, so I applied here this formula and directly multiplied x square inside this box. If you open this you will get this, and you multiply x square, so x square a square, x square, and I have integrated, that's why this x cube, this here x square, because here I multiplied here x square a square, so if you integrate x square, then become x cube. Okay, so that's why a square into x cube by 3, simply integration. Okay, you people know. Okay, so simply integration. Now here apply the limit, this is 0 to a limit. Okay, so right, so now you finally get this denominator after integration, after applying limit here. Okay, so you will get here now. So you can now write. So one thing I will tell you, right, so this become this 8m 8 pi square m. Okay, so I have died how this minus 1. Okay, so I have doubt here something, how this 2 is coming. So this 2 is coming after differentiate these things, you will get this. Okay, 0. Oh, here you will get 2. Okay, if you differentiate these things, so you will get 2. If you differentiate differentiation of dx x square, so you will get 2x. Okay, so this 2 in first differentiator you will get 2 is here in multiple, and again second differentiation you will get 2, only 2. Okay, minus 2. That's why this this 2 is come here. So 2 is 2, 2 say 8 cancel out, 2 into 4. Okay, so here 8 4, and here is you have minus sign, and here is also you have minus sign. So basically you can either you can multiply here, or you can cancel this minus become plus, but I multiplied here, so this is positive, this is negative, so I put here integration of this plus x cube, integration x square become x cube, so directly I put here. Okay, so this become x cube, so here actually this is x cube. Okay, not x a, this is x cube by 3, and this is ax. Okay, I think this is also square. Okay, because this here 1x is remaining, so ax square here I written, but this. So now applying the limit 0 to a. Okay, so here you will get this minus h square upon 4 pi square m, and in numerator is after applying limit a is 0, so you will get a cube by 3 minus here a cube by 2, because already a is present, and if you applied a on x square, after multiplication you will get a cube by 2 this, and in denominator you will get, after taking LCM all these things, so you will get this 30 and this. Okay, so finally in denominator you will get this term, because in the, for easy solution in question they have given easily value of this integration, but I calculated, I also got same value, a 5 by 30. Okay, right. So now this things is minus 3 is the bigger value, that's why sign comes minus after subtracting. So this minus is plus. Okay, so this is become a cube by 6, and okay, a cube by 6, and this is in denominator a 5 by 30. So 6 into 5 become 30, so 6 divided into 5. Okay, and now a cube is a cube cancel out, here remain a square. So you will get finally plus 5h square 4 pi m a square. This is energy of this ground state. Now we have to find percentage error. Okay, so percentage error calculated energy, ground state energy minus given this true ground state energy upon given ground state true ground state energy into 100, because we have to calculate percentage error in 100%. Okay, so simply you can calculate, you will get 1.32%. okay, right, hopefully you understood. Okay, so now move to the second question. So second question is basically from radioactivity. Okay, and question says is some fission reaction is given to us, uranium 235 atomic mass upon atomic number into atomic number is 92, which thermally neutron is represented here. This uranium fission is thermal reaction happen with neutrons. Okay, and from the uranium 236 atomic mass with 92 atomic number, and again fission this form 41 niobium and 51 Sb, and this niobium and Sb are primary fission fragments pairs which undergo series of radioactive decay to form stable nuclei, here X3 and F4, and these value we have to find. Okay, so this is basically radioactive chemistry, and this is radioactive decay reaction, and this is basically fission. So how to approach this type of question? So as I also mentioned in this fission equation is given to us. Okay, and how to approach this types of question means how to find x3 and x3 and y4 value. So basically first we have keep in our mind x3 x4 will form daughter nuclei which is more stable, which is stable product. Okay, and how to approach this daughter nuclei, because uh, this x3 x4 x3 y4 form less atomic or equal mass number of this NB and SB. So if you here see NB mass number is something, means if we multiply 4 into 24 and add plus 3, you will get this something 4n plus 3 types of this mass. Okay, and if you write in this way, you will get the daughter nuclei, which is the order of 4n plus 3. Okay, so if you multiply this, 4 into 24 is 6 and 8 9, so 96 plus 3 will become 99. Okay, so this is correct. So you have to remember this formula 4n plus 3. Okay, for these types of mass number. Okay, and where n is the integer, so you can use for daughter nuclei 24, 23, 22, 21, like that. Okay, so and if you see SB mass number 4 n plus 1, so here this will gives data nuclei like this 4n plus 1 types. Here also n is integer 33, 32, 31, 30, like that. So how to select using this formula 4n plus 3 for this niobium and 4n plus 1 for this SB. Okay, so now we see the option. If see option first, so option first, if you see 87 brominium atomic mass is 87, so this is not like niobium. Okay, because niobium is 99 and rule is for 99, rule is 4n plus 3 are n values, which here n is suitable for niobium 99 is 24 and maybe less than 22, 3 n value maybe 23, 22. So if you choose n value for this brominium 87, so you will not get from this value. Okay, so you will not get 87, right? So this option will not. And if you see TC 124, so X3 will not perfect for will not tally 4n plus 3 rules. Okay, now if you see Y4 for this TC, so atomic mass is 124. So if you see for SB rule is 4n plus 1. So here you have given my value n is 33, 32, 31. Okay, so if you here SB's atomic mass number is 133 and using n value is 33, but here given TC is atomic mass 124. Okay, so this is less than of 133. So here you will also not get daughter nuclei because daughter nuclei means you will get less or equal atomic mass of the radioactive elements. So first option will not correct. Now see second option. Second option is see ruthenium, 99 atomic mass number. So X3 maybe 99. You check once. X3 means 4n plus 3 rules. So 99 here is given. Rule is following. Okay. So X3 may be this ruthenium possible. Now check cesium. Cesium also following rule 133. So this B will be the maybe the correct answer. Okay. Now check C is not possible. D is not possible. So ruthenium and cesium will be the correct answer. Okay, for this daughter nuclei. Okay. So correct option is for this B. Correct option B. Option B. Okay. So we have select according to the option by using this formula. Okay. This is for SB and this is for niobium. Now if you see question number 3rd. So question number 3rd is basically from solid state. Okay, and question is asking the weight of halogens X, and first I am reading the question. What question says? Question says consider that AgX silver halides crystallizes in a rock salt structure. The density of silver halide is 6477 kg per meter cube and unit cell length is here A value is given 57.5 picometer and atomic weight of silver is given to us 107.87 gram mole inverse. Okay, atomic weight of halogen in gram mole inverse we have to calculate. Simply here given AgX, which is the rock salt structure, cubic, and for cubic system and numbers of atom will be 4n. Okay, and density is given 6477 gram meter per meter cube. Okay, and A is given unit cell length and atomic weight is given. So simply this is very simple question. Since we know the formula, density is equal to n into this is molecular weight n upon Na into A cube. So Na is Avogadro number we all knows, and now we have to calculate the whole AgX atomic weight. Okay, so whole atomic AgX molecular weight. So we have to find m. So we convert because we have to calculate m, molecular weight of AgX. So this value goes this side and this value will become down. So here written simply like that. Since we know the, and simply we put here density Na Avogadro number, okay, and A 577.5 picometer and N is equal to 4 for this cubic system. Simply you will get the molecular weight of AgX, okay, but you have to find the weight of X. So simply if you add weight of Ag and X, then you will get the molecular weight of AgX. So simply here atomic weight of Ag plus atomic weight of halogens is equal to molecular weight of AgX. You know the value of, here given the value of atomic weight of silver, here this value is given, you put here, and this is unknown value you have to find, and you have calculated from this formula. You put, simply you will get X atomic weight 79.07 gram mole inverse. Okay, it's very simple. Only you have to see here and find the first molecular weight of AgX. Then you can simply here you will get. Now question number 4, this is from kinetics. Okay, so it's very good question and simple also if you know the formula. So question is, in a reaction which is given X, Y form from X, rate constant K1, and Z form from Y, rate constant K2, okay, and K1 K2 value is given. So question I am reading, in a reaction reactant X is converted to products Y and Z consecutively with rate constant 6.0 into 10 to the power minus 2 minute inverse, and K2 is given 9.0 into 10 to the power minus 3 minute inverse respectively. K1 K2 is value is given to us. If the initial amounts of X, if you see X, initial amount of X is given 12.5 moles, the numbers of moles, so we have to find the numbers of moles of Y form after 10 minutes. So how many moles formed Y after 10 minutes? So N value we have to calculate for Y, okay, at a time of 10 minutes. So simply you apply the formula. It's little bit typical formula but simple here, okay. So N moles of Y is equal to, this is basically for intermediate, this formula valid for intermediate, okay. So we have to, when any question is given these three spaces and Y is the intermediate, then you can apply this formula, okay. So N moles of Y is equal to K1 upon K2 minus K1 rate constant, here K1 K2 into concentration of X of reactants initially, bracket of exponential minus K1T minus exponential minus K2T. So simply K1 K2 value is given, X value is also given, initially is 12.5 and T is given at 10 minutes. So you simply put here, you will get 5.4 moles. So this is very simple question. So thank you for your patience, and please like and subscribe, don't forget. Okay, so up to here all over I finished. I covered mostly all physicals and some other inorganic organic question, which is basically most important in exam points of view. Now in next video I will solve the problem gate 2019. Okay, so hope you guys understood these all 4 questions. Okay, if you have any doubt, so if you write in below comment section. Okay, I will try to explain you. Okay, so good night, bye bye, thank you for watching.